Okay, so today we are adding and subtracting polynomials. So, I mentioned a little bit about what you need to do here before, but the big key is that you can only add or subtract like terms. So, what is a like term? Like terms are terms with the same variable or variables raised to the same exponents. So it doesn't matter what your term looks like. Let's just say I had, I don't know. Say I had 4x to the third. Okay, so there's one term. If I wanted to add or subtract another term to this and actually be able to combine them, it has to be another something x to the third. Because it has to be the same exact variable raised to the same exponent. So, say I had, I don't know, minus 17x to the third. Because these both have x to the third, that means that these are like terms. So once you figure out, I have like terms, all you do is you do the math on the coefficients, the numbers in front. And then you're just going to leave the variable with the exponent all by itself. It's like I have 4 of these things, and I'm going to take away 17 of these things. So I would be left with negative 13 of these things. See how the x to the third doesn't change? It's like 2 inches plus 6 inches is 8 inches. It doesn't become 8 inches squared or something. It would if I were multiplying them, but I'm not, right? 5 socks and 6 socks make 11 socks. That's all I'm doing. So it's 4 of these, negative 17 of these, put them together, that's what I get. Okay? So say you had something like 2x minus x squared plus 7x plus 5x squared. So you had this. Well, if you're going to try and simplify this, I always recommend that when you have a whole bunch and I need to combine them, always start with the highest exponent. If you get in that habit, then your answer will automatically be in standard form and you'll never need to rewrite it. Yeah, so my highest exponent that I have here is to the second, right? There's one, and then I do have another x to the second. So these two are like terms, so I can put those two together. So what would I get when I combine these two? 4x squared, right? Because that's a negative 1, and that's 5. So negative 1 and 5 gets me 4x squared. So those two combine to 4x squared. And then I move down. I did x squareds. Now let's do x to the first. Just so happens there's 2 of those. They're like terms, so I can put those two together, and I would get plus 9x. And that's it. You just have to make sure you have the exact same variables raised to the same exponents. So don't get tripped up by something like this. Say I had 10x squared y minus 5x squared plus 6y, and then maybe I'll do plus x squared y. Say I had this example. Yeah, so be careful here. If I just look at these first things, I have x squared on both of them. He has a y and he doesn't. So even though they both have x squared, it doesn't matter. Everything has to match. So these two are not like terms. However, these two are. They both have x squared y. Do you see that? Same variables, same exponents. As long as they totally match, then I can combine them. So if I put these two together, that's how I get the 11x squared y. Do you see that? Because there's really a 1 in front here that we never write. So now I have 11x squared y. And then who would come next? Negative 5x squared. And then the plus 6y. There's nothing to combine them with, so I just leave them. And that's the best I can do. You can't go any further than that. Try this one. I know it seems easy, but the answers always amuse me. That's it. It's just 5x squared. So many times kids just think, oh, x squared minus x squared, it's just gone, the answer's 6. It does not work that way. It's 6 of these minus 1 of these, so it's 5 of these that you're left with. Yep. Yeah, it's like, no, it does make sense though, because think about when you add 2 apples plus 3 apples, you just call it 5 apples, right? You don't call it 5 apples squared or something. It's 6 of these minus 1 of these, so these stay the same. Yeah. I'm literally taking this many and just putting them together. Yeah.
But if it's x squared, say we substitute a number in for x, like say it's 2, the x is now 2. That would be 4, and then if the x was 2 on both of them, it would be 4. 4 minus 4, those would cancel out. It would just be 6.
You're not doing order of operations though. You'd have to multiply first before you subtract. Yeah.
So if it was just x squared, yeah.
Let's try another one. Trying to think of this. I mean, adding really doesn't get that fancy. The only other thing I could think to do is maybe we'll.
X squared minus like x squared.
I was gonna have you try distributing. All right, try that one.
You.
Oh, good. I found my worksheet. It's right there the whole time. You have an answer? Hang on to it. Okay, give it a shot. So, first we have to distribute, right? So, let's work ourselves through that. What do you get when you do x times x squared? X to the what? Third, right? X times x squared, x to the third. X times 4x. 4x to the second, and then x times 2? 2x. Now I just have these, I'll just rewrite them. Okay, so now I've done the I distributed. Now I want to go ahead and write my answer. You should always start with the highest exponent though. So then your answer will already be in standard form. So my highest exponent this time is X cubed, there's no other x cubed, so it just stays x cubed. And then go down to x squared. What do you get when you combine all the x squareds?
6x.
Plus 6x squared. Go down to just the x's.
Or minus x.
Yep, negative 1x, or just negative x. And I'm done, right? I combine them all. And I can't go any further, so I'm done. Pretty easy? Okay, on your homework, I just want to do one problem like you might see there. Oh, actually, before we move on, how would you name that thing?
Cubic trinomial.
A cubic trinomial, right? Third degree, 3 terms. Cubic trinomial. So on your homework, you're going to see something like this. Where they want you to, they have this in parentheses plus this in parentheses. Guess what? When you're adding, what do you think what do you think I have to do with these parentheses?
Literally nothing.
Exactly. You do nothing. You can totally ignore them. If it's addition, as long as there's a plus sign in between the parentheses, they're just saying add this polynomial with this polynomial. But in order to do it, you do nothing with the parentheses. You ignore them completely. So it's the same thing as if you were doing this. The exact same thing.
I feel like it just does that to make you not get overwhelmed.
It can't. Now, when we do subtraction, it's a big deal. But for addition, I don't want you getting hung up on the parentheses like you have to do something with those. You don't. If it's addition, ignore them, and then just combine your like terms. So your highest exponent is
2 squared.
x squared, so combine those and you would get
4x squared.
4x squareds. Put
Minus
minus 9x.
minus 8.
Does everybody see where she got those things from? We getting a handle of how this works? And then if I asked you to name that polynomial, you would say it's a what?
Quadratic trinomial.
Yes, a quadratic trinomial. Quadratic because the highest exponent's a 2. Trinomial because I have 3 terms. Alright, so that's about as hard as addition gets. Subtraction, okay, that could be a little bit tougher. But not if you follow my 2 steps. You ready? Subtracting polynomials. Let's say I tried to do basically the same thing that I just did with addition, but now with subtraction. So say I had, I don't remember what it was, 5x squared plus 2x minus 7, and then I wanted to subtract from that. I don't know, 3x squared minus 12x plus 6. Something like that. Who cares? Go ahead, tell us.
Okay, so you would take the negative sign and you would make the 3x squared negative, the 12x positive, and the 6 negative.
Yeah.
So just doing
Sure.
opposite.
You have to distribute that negative.
Yeah, if
So, right. If there is a minus sign between the parentheses, it makes a big difference. You can't just ignore the parentheses here. You have to distribute that negative.
5x squared plus 2x minus 7 minus 3x squared plus 12x
Mhm.
minus 6.
So I always rewrite it. Yeah. Now the first thing doesn't change because I'm not subtracting that. So that's going to stay as it is. But now you distribute that negative. Minus 3x squared plus 12x minus 6. And then I do the exact same thing. Now that I've distributed the negative, now I just combine like terms. That's the 2 steps. Distribute the negative, combine like terms. That's it. So for subtraction, the parentheses do matter, but it's pretty easy to handle. Just distribute, and now I combine like terms. So my highest exponent is the 2. So when I put the x squareds together, I would get 2x squared. Go down to the x's. 14x. And then negative 13. That's it. You just have to make sure that you don't forget to distribute that negative. That's all there is to it. So let me give you one to try without me telling you what to do. Let's do... Try that one. That one's a little bit different. You have an answer?
Wait.
Oh. Sure. No. If I was just subtracting a monomial, so for example, if I wanted to take the number, I don't know, x squared plus 3x, and I just wanted to subtract 5x from it, I might just write it like that, and then I just combine like terms. But if you do have parentheses with a minus sign, you have to distribute it.
Is that like 7 tenths?
Okay. So, first, you're going to distribute the negative. And don't try and do it all in your head and just skip all these steps and just write the final answer. Because I can't tell you how many times kids try and do it and then they miss one negative and now they lost a point for a stupid reason. So, you should, this first one doesn't change. It is exactly as it is. But now I minus all of this. So you turn into a plus 3x squared and you turn into a minus 2x. Now I just combine like terms. Highest exponents to the third. There's no other ones. Then I go down to squared. There's 2. Negative 14x squared. Go down to x to the first. There's only one of them, so it just stays. And then just the numbers at the end, plus 4. It will already be in standard form as long as you started with the highest exponent and worked your way down. Right? And then my answer automatically is in it. If I asked you to name this thing, it would be a what?
Quadratic, quartic, no,
Cubic, yep.
oh god.
Cubic 4-term polynomial.
Like the last one. It's called.
Wait, why is it 4
Because you got 4 of these chunks. 1, 2, 3, 4. Huh? That's by degree. So the exponent is 3, so that's why it's cubic by degree. And then 4-term polynomial. Mm-hmm. No name for what? Oh. Yeah. You actually do add them if you have more than one variable. So if, let's say my expression was this. And I wanted to know what's the degree of this polynomial. It is actually a 2 because that's a 1 and a 1. So this term is second degree. But that comes up so rarely, so. Oh, hi!
You're a little late.
We are subtracting polynomials. So, the only other thing that I want to show you that comes up very rarely, but whatever, just in case you see it. Sometimes some people like to try and, remember when you were first learning how to add and subtract numbers and you always did it vertically? Like if I wanted to add 141 plus 37, you write them like this. You didn't write them like that. You could, right? But if you were actually going to do it, didn't you write it like this so you could add in the columns, right? So you can do that with polynomials. With addition, it's great. You just make sure that you line up all the like terms. So for example, you might see, say I had x squared plus 3x minus 10, and then x squared minus 5x plus 6. And if you wanted to add these two polynomials together, see how they're already kind of lined up like terms, one underneath each other? For addition, yeah, this is fine. You can do it this way, and it's pretty easy. Negative 10 plus 6 would leave me where? A negative 4. Positive 3 minus 5, negative 2x. And x squared and x squared would be? I'll give you a hint.
2x squared.
2x squared, right? There's one of these plus another one of these, so I'd get two of these. So I'd get 2x squared. So yeah, that's great with addition. With subtraction, I would never do it vertically because it's such a pain in the neck. So here's what I worry about. If you tried, say you had this, I'll do the same exact problem, but I'll do subtraction instead. So if you ever saw it written vertically and you were going to subtract, first of all, it would have to be written like this, where you're subtracting with parentheses around this. You still have to distribute the negative. You have to subtract each one of these. That's why I'm saying it's so stupid. I would never, ever, ever write it like this. But if you, I don't know. So here's what I would do. So here's my top line, and then I would distribute that negative through. So now it's a negative x squared, a positive 5x, and a negative 6. And now I would just add them. So now that's negative 16, 8x, x squared minus x squared, what's that?
0.
That cancels out. So then this would be my final answer.
So wait, it would be a linear binomial?
Linear binomial. But again, you would never, ever, ever, why would you bother doing this? The only reason why I'm showing you is because I think they have one like this on your worksheet that I'm going to give you. So,
You can always just rewrite it.
yes, I totally would. So with polynomials, I would rewrite it so that it read like this. X squared plus 3x minus 10 minus all of this. X squared minus 5x plus 6. You still have to distribute the negative and then combine your like terms. So it's not really saving you any time. But addition, I could see, oh yeah, you could do it vertically. That's not so bad. Subtraction, nightmare. Bless you. Okay. So, any questions before I let you try some? All right.